All right, let's jump right in. Today, we're going to look at a really ambitious vision, and it's all coming from two companies that are working together, Dart Meadow and Radical Deepscale. And they're not just making, one single thing. They're building an entire ecosystem of tools that are designed to completely change how we measure, how we create, and maybe even how we think. To really get how deep this rabbit hole goes, you got to start with this quote from their own work. They're basically defining an AI brain as a math problem where the answer isn't a single number. Instead, the answer is the whole process of research and discovery itself. It's like the solution flows towards an answer, kind of like a river spreads out into a delta to find its way to the ocean. This sets the stage perfectly because you see, they're not just treating AI as an engineering problem, but as a whole new philosophy for creation. So who's behind all this? I mean, who's coming up with these wild ideas? Well, it's actually a team effort, a partnership between two very specialized groups. Let's get into who does what.
So, on one side, you've got Dart Meadow. They're all about the physical stuff. We're talking aerospace, engineering, advanced materials, things you can actually touch. Then you have Radical Deepscale. They're kind of the brains of the operation, building the digital foundation, all the software, the hardware that makes this whole thing tick. So one's focused on atoms, the other is all about the bits. Makes sense, right?
Okay, so here's where it gets really cool. Their whole approach, it's different. They believe that before you can even think about building new stuff, you have to be able to describe the world in a totally new way. And for them, that all starts with creating a new language for measurement. The core idea here is something they call the finite arc. Now, think about it. Most of the ways we measure things are based on perfect shapes, right? Like circles and straight lines. But the real world? It's messy. It's chaotic. Think about the coastline of a country or how water flows in an engine. That's not a perfect circle. So their tool, ArcEdge, is designed to precisely measure these messy, irregular shapes. They basically had to invent a whole new kind of ruler because our old ones just couldn't measure reality as it actually is. All right, so you can measure the real world with incredible accuracy. What do you do next? Well, you try to simulate it, right? And that's exactly where ArcLake comes in. Think of it as a virtual chemistry lab built by Radical Deepscale. It takes all those super precise measurement principles from ArcEdge and uses them to build a digital playground where you can model molecules and see how they'd behave in the real world. It's that perfect bridge from just measuring things to actually creating things virtually. And this right here, it just perfectly sums up their whole philosophy. I mean, playing around in this virtual lab, ArcLake, it's not just for fun or for some research paper. Nope. It's the actual blueprint for creating real physical stuff. And this is where Dart Meadow, with all their engineering muscle, steps in. Just look at this. This isn't some theory. It's a literal recipe. This is the exact chemical makeup of their Hercules alloy. Check out the super specific percentages. Aluminum, titanium, tungsten. Getting this precise is only possible because they can model and simulate all those chemical reactions perfectly before they ever mix a single thing. And believe me, it gets way more advanced than that. What you're seeing here is the recipe for a super specialized alloy, the T11ZC, made for hypersonic engines. The reason it's so complex is because they're engineering it for very specific jobs, like surviving insane amounts of heat without falling apart. This isn't just about making better metal. It's about creating materials that can do things we've only dreamed of, opening up whole new worlds in transportation and, even energy. Okay, so let's recap. You've got these incredible tools to measure, to simulate, and to create. But who or what is going to use them? What kind of brain do you need to really take advantage of all this? Well, that brings us to maybe their most mind-blowing project of all, a completely new kind of artificial intelligence. Think about how most AI works today. It's basically like showing it a million pictures of a cat just so it can learn what a cat looks like. That's what they call a looping network. Their model, LEATR, which, by the way, stands for Lead Edge Ash Tree Reflex, is totally different. It's reflexive. So instead of just matching patterns, it's designed to act like a reflex. You touch a hot stove, you don't run through a database of burn injuries, right? You just pull your hand back instantly. That's the kind of immediate, intuitive problem solving they're building. So how in the world do you build an AI that thinks like that? Well, you don't just feed it data. You give it a brand new set of building blocks. Take a look at this list. They call it the order of natural tools. Think of these not as objects, but as like core concepts for solving problems. A maze isn't a picture of a maze. It's the concept of navigating a complex path. A hammer is the idea of applying force.
A knife is the idea of dividing something. They're trying to build an AI that gets the function of a tool, not just its appearance.
And you know it. If you've got revolutionary software, you're going to need some revolutionary hardware to run it on. And this is it, the Aerial NPU, or Neural Processing Unit. It's their own custom-designed chip, a piece of hardware built from the ground up specifically to run that reflexive LEATR system. So they're not just writing new code, they're literally forging the silicon brain for it to live in. It's a perfect marriage of the software and the hardware.
All right, let's pull all of this together. We've talked about tools for measuring, crazy advanced materials, a whole new way of thinking about AI. So what does it all mean? What does it add up to? Well, it's all about building a complete next-generation toolbox for innovators.
To really bring this idea down to earth, check out this post from Reddit. You've got a game developer who's trying to build a blacksmithing game, and he wants to give the player this ultimate freedom, a sandbox to create anything. He's struggling, says it's buggy, but you can feel that passion, that drive to create a better tool for people to express themselves. And then this comment from a user named Swat Snoopy, it just hits the nail on the head. I have dreamed of video games achieving this level of control. He talks about just being able to push or pull a shape and how his mind would literally explode. That deep human craving for better, more intuitive tools to create, that's exactly the problem Meadow and Radical Deepscale are tackling, just on a massive industrial scale. And that, right there, is the grand vision. It's the whole shebang. The Arc Edge tool, the Arc Lake simulator, those amazing alloys, the LEAR AI with its custom aerial chip, they aren't separate projects. They're all pieces of one single integrated system, the Innovator's Toolbox. A set of tools meant to empower literally everyone, from students and teachers to the top engineers in the world, to build whatever comes next. So it all comes down to this one big question, doesn't it? For the last 100 years, we've been building tools that are just faster, stronger versions of us. A better hammer, a faster car. But what Meadow and Radical Deepscale are trying to do, they're building tools that think differently from us. And that just makes you wonder, what incredible new things could we create? What discoveries are waiting for us if we had tools that don't just help us think, but challenge us with a whole new kind of intelligence?